All right, we're in AP Calculus lesson 1-6, average rates of change. So, let's go ahead and have someone read. All you gonna read?
Sure. There's no objective.
Oh, the objective. By the end of this lesson, let me make sure I know what I'm doing today.
I think Georgia said 1-7 was the last one, or this was the last one.
We will, I guess I can check really quickly, can't I?
Because you also put the reminder in yourself.
1-7 has an objective, 1-6 has no objective. So my objective today is be able to find the average rate of change from a graph and a table. That's it, yeah?
And be able to find the average rate of change from a graph.
Exactly, yep. All right, so Diego, do you want to read my paddleboarding?
Okay. Mr. Sandell went paddleboarding on June Lake last weekend. The number of meters M he has paddled at this time T is modeled by a function D for 0 is less than or equal to T, which is less than or equal to 60 minutes. Value of T, D of T at various times is shown in the table below.
Yeah, so most of the time in AP Calculus, they will be giving you a table when they're asking for an average rate of change. And in order to demonstrate what's going on here graphically, I would like you to plot these points. So spend a few minutes right now plotting these points on our graph. Once you finish your table, go ahead and check to see if it roughly looks like the table that I have up on the Promethean board.
Yep.
Cool. So this is one of the hardest lessons to learn about tables in AP Calculus. You don't know what happens in between. It's that simple. And to demonstrate that visually, I can tell you that in order to go from here to here, I could have, well, let me do something that's more dramatic. I could go up here and then I could be flat. I could go be flat here, then I can come up right here. I could go and do something weird like that. You don't know what happens in between here. I can't go back down in terms of the nature of the function because I can't go a negative distance. Distance is always positive. So I have to keep going up. I have to keep going up. But the way that I keep going up, I can do whatever I want in between these points. The thing is, you don't know what happens in between these points, but you can still give some general observations. So I can tell you the average speed over the entire distance if I want, and I want to first define what average rate of change means. So go ahead and above average rate of change, you can cross it off if you don't like it, and I'm just going to change this to slope. Every time that you see the words average rate of change, just automatically change that to slope. It will be a bit tricky for us to remember that because there's a bunch of things to remember in AP Calculus, but that is slope, and we define slope as what?
Y equals mx plus b.
Slope, well, y equals mx plus b is a slope-intercept form of a line. How do
Isn't
I
it
define
y
that?
over x?
Something about y and x, yes. So slope I define as the change in y over the change in x. There's a few different ways to define that. You can also define it as, we used to define it as y2 minus y1 all over x2 minus x1. And again, you can switch the 2 and 1, so it's y1 minus y2 and x1 minus x2. That's also okay. I will give you yet another definition that is more in the function notation that you're used to, and it's just converting the y's into f of x's. So if my function is f, then it's going to be f of your first x1, and maybe I'll say the second. It doesn't really matter if it's x1 or x2. I'll just say x2 in order to match this y2 over here. So you can say f of x2 minus f of x1 all over x2 minus x1.
And so does that mean the height when it's at x?
Very good.
Okay.
Yeah, so what we're doing is we're finding the difference of the heights, and then we're trying to find the distance in your horizontal x direction. You can use all of those, anyone that is easiest. Yesterday in pre-calculus I recorded a video where I was using this in a very general way in order to fly through problems, because I was just like, how much do we change between 1 and 2? The change was 1. There's no actual subtraction problem. You just ask yourself, how much did we change? All right, so, and this is kind of the other important bit in terms of the graphical interpretation. Graphically, if I just look up here, it's just represented as a line between 2 points. Just a simple line. And when I say line, I don't mean a curvy line, I mean a straight line. So let's go ahead and see what I'm supposed to do down here. In example 1, I want us to sketch the line representing the average rate of change. Again, as soon as I see average rate of change, in my mind, I'm crossing that out and I'm just writing slope. Sketch the line representing the slope over the entire interval. So if it's the entire interval, I'm going to, you can use a ruler in the back if you want, or you can try to freehand it. I can have technology, ha ha ha, and boom, done. It's a line that connects the start to the end. That's the entire interval. What I'm trying to do is I'm going to make a straight line for whatever interval it's asking about. In AP Calculus, it usually asks for random intervals. It'll say between 20 and 55, between 0 and 20. It'll randomly give you an interval, and you're expected to find the slope on that interval. And you can just use that function, or the values in the table to find that. So I sketch the line, done. Now I'm actually trying to find the average rate of change. Again, I see the words average rate of change, I cross it out. And I change that to slope. So part A is asking us to sketch, part B is finding us to actually calculate. So saying calculate the slope on that interval between 0 and 60. And I need to indicate units. Whenever in AP Calculus it says indicate units, they will take off points if you don't have the correct units. So let's calculate the slope. So I can calculate the slope either using the table or using the graph. The graph is nice because I can see that it's a positive slope. And then using the table, what I'm essentially using, and I'm going to circle these, and you guys should as well, I'm using that table value, and I'm using that table value, and here's why. It asked me for the t 0 to 60, so I went up here to the t value of 0 and 60, which corresponded to 0, 0, and 60, 1,800. So far, so good. All right, slope formula, here we go. So, I'm defining my slope, and I'm gonna say, in this case, my function is not f, but it's d. You can see that it's d, capital D of t for my distance function. So I'm gonna come down here and I'm gonna say that this is overly formal. You don't actually have to show this work if you're doing the AP test. You can say d of the first point, or the second, it doesn't matter. First point or the second point. Which one do we want to do?
First point.
First point. First point was 0. D of 0 minus d of what?
60.
Good. Diego, what's in the denominator?
I'm gonna put, so it's not x anymore, is it?
It is. It's well, I mean, it's t, but now you're filling in those
T.
numbers.
It's 60 minus 0. Sorry.
What'd she say?
I'm sorry,
So-
Diego. I sneaked you.
So I'm gonna write down something wrong. This is wrong because we did 0, 60. This should be 0, 60. The order here matters. So you're allowed to, if you want to do 60 minus 0, that's fine. But that means that these need to be swapped. So do you want to do 0 minus 60 on the bottom, or do you want to do 60 minus 0 on the top?
How about we just do 60 minus 0? That seems
Okay, so I'm going to go ahead and erase this top here. So that was something now that is correct. And I'm going to say capital D of 60 minus capital D of 0. Now this is correct. You just need to make sure that you have the same number over the same number. Okay, so what was D of 60? What was the, in air quotes, the Y value, the height at 60? And you can tell by the table.
1,800.
Yeah, the table told us 1,800. So I just bring that down here and say D of 60 was 1,800. minus, what was, do you have 0? Shout it out.
0.
0, and I can do the hard math for you guys. 60 minus 0 is 60. Now I need to do, again, essentially subtracting zeros as if I cross it off. I need to do 1,800 divided by 60. Cool little trick. Cross off a 0, cross off a 0. It's really 180 divided by 6. 180 divided by 6 is close to 18 divided by 6, which is the 3, and then add on the 0, and we get 30. So that's the right answer, right?
Yep.
We're missing something.
The unit.
Yes, we will lose points if we do not indicate units, because it told us to. If it explicitly tells you to, you have to do it. All right, so what are our units here? And come up here, and we need to read the problem. Yeah, so let's circle some units. I have some meters, and I have some minutes. So what do we find here? We divided, this was meters, and we divided by minutes. So this is going to be meters per minute. So it's going to be M is meters, minutes is MIN. So 30 meters per minute. Excellent. On to example number 2. This time I do not give you a graph. Again, if there was a graph, we would just connect a line. Oh, it does have, I put the same exact equation here. I totally forgot about that. Okay, let's go ahead, and I want you to go ahead and sketch right now. So you're going to flip over the front side, and this time the interval is not 0 to 60, it's 5 to 20. So for 5 to 20, sketch that line.
Right here.
So go back to the front, 5 to 20. Where's 5 to 20? Oh, I'll do this one in lime green.
Is it a small
Done. There it is. So is this slope going to be more or less than that previous line?
Less.
Why do you think it's going to be less than?
Well, let's see. Maybe because like the line's kind of small. To be able.
Yes, it is smaller, but if I have a small line like this line right here is going to be a lot higher value than this line down here.
Because that one has going in both directions. This one doesn't have to.
Okay, let me go ahead and fix mine. Now this line right here, this line segment right here, also have a steeper slope.
Oh, it's fitting with the slope.
So it's all about how steep it is. You can say that that blue line is steeper than that green line. So we should be expecting a higher number than 30. Let's see what we get. So I'm going to come back over here and actually do the calculation. So we did the sketch, you can check that one off. And now we need to actually find the average rate of change. Every single time that you see average rate of change, cross that off and we change it to the word slope. All right, what are we going to do? Alden's already doing it. Diego, go ahead and do it. And if you guys get stuck, you can look up the permission board.
We're gonna put a D.
Yep, take your time. You guys got this. Yeah, Alden.
Honestly, I feel like I understand this so much better than anything we've done this year.
That is because this is from Algebra 1. All right, how do I know this is 20 without doing any calculations? What's my quick way of doing mental math? How do I do 300 divided by 15? Any tricks you guys know?
Hello.
Yes, but I'm not gonna tell you, because I already learned it.
In my mind, like remove one of the zeros, 300 make it look like different.
Exactly, so you make it look like 30. 30 divided by 15 is
Yes.
2, add on the 0 again. So 2 with a 0. There it is. That's exactly what I did as well.
So did you like make your pen fancy to make the writing look so cool? Like the word slope looks really awesome.
I
Is
just
it
have
like a-
nice handwriting. So-
But it's not just like a skinny line, it's like there's some
I
texture
have,
to the line.
I have 3 different options on my iPad. I can do fountain pen, which is what I'm currently on. I can
Okay,
do
that's
ballpoint pen, which looks lame, and brush pen, which is more
Too
like,
foo-foo.
it's way crazy.
So I don't like the ballpoint pen ever,
Yeah,
for
so
any
this is,
reason.
this is ballpoint pen. You can see that it doesn't
That's
look
what
that
I
nice.
usually see on those.
And
I
then-
guess it's good for astronauts.
And then brush pen looks like this.
Ooh, pretty but distracting. It's distracting. And I'm sorry to interrupt, and I'm sorry that George isn't here. Yes, you're excused from talking to the art panel. I'm gonna get sophomores to do it. You guys have way too rigorous of schedules. I'm sorry, I would have probably said no,
Yeah, well,
had I been in the loop beforehand. Also, seniors, Tuesdays are fine with me for off-campus lunch. Today has been approved. I emailed you and your families.
okay,
Okay,
thank
so
you.
you know, yeah. Well, today because Tuesday already passed. Tuesday, Thursday to this week, and then Tuesdays. Thank you, everybody.
Thank you, Miss
Thank
Nelson.
you. I like your outfit today.
Oh, thank you. I was hoping I'd get a compliment because I tried to do like a white and black blocking. See you later.
That's it. All right, that concludes our lesson. So, again, our objective was being able to use, be able to find the average rate of change on a graph and a table. How well do you think you can do that? This is 5,
Still need a little bit of practice.
3, and 5. Well, thank you.
Wow.